How's it going, fellow scratchers? Today I'm going to show you how to make arcadey car physics. As you can see, we're not in Scratch but in Turbo Warp, which has more features and is just generally a bit better to use. And we're going to turn this empty project into a car controller that can be used for any racing game basically. It allows you to make 3D models from PNG sprites, where you basically just stack a bunch of them on top of each other. Anyways, let's get started with the coding. I'm going to start off by renaming my variable to car number, which you're going to need later. So this is if you want to have more than just one car. Set this to 1 for now, since we want to start off with the first car. Then you have to make a few lists, such as top speed, acceleration, handling, grip, and brakes. First of all, we're going to go for the top speed. Since I'm using the same 3D model as in my how to convert Blender models to Scratch video, I will be using somewhat realistic stats for that car. So the top speed is 240 kilometers per hour. Just type in 240 for that. Then we need the acceleration. Now I figured that the unit for this should ideally be kilometers per hour per second. Acceleration is the change of velocity per time unit. So kilometers per hour is obviously a speed unit and seconds is a time unit. And so we're going to take the kilometers per hour and divide it by 1 second. And then we get the acceleration value we need. So the Honda S2000 has an acceleration time from 0 to 100 kilometers per hour in about 6 seconds as far as I'm concerned. So we're going to have to divide 100 kilometers per hour by 6 seconds, and then we get a value of 16.666666 and a lot of sixes to follow that up. And now we can paste this in here. That's from the calculator. Make sure you replace any commas in the number with points, since Scratch doesn't like to work with commas and it just screws everything up. Now with the approach we're going to be using, which links top speed and acceleration together, sort of, we're going to need a value a little bit higher than this. So I say we go for something like 20 or 21. Now for brakes, we're going to use the same unit. But since the brakes are obviously a lot stronger than the engine in most cases, we're going to increase this value to about 60 or something. This should be fine for the S2000 for now. Now onto the handling. I usually set this to the amount of degrees I want the car to turn. So for example, if I hide all of these, then if I want this to turn 5 degrees when I press the D key, which is going to be used for turning right, then I type 5 here. Then we still need the grip. The code is hopefully going to explain it on its own, but I think at the moment we can go for something like 0.9 or 1 or something. Then we need a few more variables, such as speed, the x coordinate and the y coordinate, rotation, and the car angle. This is pretty much everything we need right now. So let's start off by setting all of these values to 0 at first. Now we need a forever loop, and this is where the fun begins. So we want the car to accelerate whenever we press the W key. So this right here is what will make the car accelerate. And if you're somewhat familiar with mathematical terms and functions and stuff, you might have heard of the term asymptote, which in this case is the top speed of the car, which means that the car is technically never hitting its true top speed defined in this list. It's going to get closer and closer to its top speed until the output of this value, drag this in place, now we can try this out by pressing the green flag and pressing W. That was fast. We don't really want that. Since Scratch is not really doing anything, just changing the speed a lot, we need to delay this a little bit, just so you can see what I mean. Yeah. The acceleration is getting slower and slower by the second, since we're getting closer to the top speed of the car. As you can see, we're now reaching 180, 190, and that is pretty much exactly what we want for a somewhat realistic car acceleration. And so we're going to put it into place again. Now onto the turning. This is a little bit simpler. So this right here is for the input. If you press A, it's going to be -1. And if you press D, it's going to be 1. And if you press none of those keys, it's going to be 0. Now, we can multiply what we have here with the handling. And then multiply this by 0.25 for the other value which we're going to use later on. And that is the set car angle to car angle times 0.8. This is going to reset the car angle back to its origin point, which is 0. And if we want to reach the handling number we typed in earlier, which in this case is 5, we need to type 0.25 in here. And now, if I press D, it should go up to 5, the car angle. And if I release it, it should somewhat slowly go back to 0 again. Same goes if I press A. If I press A, it's going to be -5, and if I release it again, it's going to be 0. Just like that. And this is how it resets the car's angle again. And if you press both keys at the same time, nothing is going to happen. Now we need an if-else block to check if the speed is greater than 0. If this is the case, we're going to change the speed of the car by this much. So again, this is taking the input of your S key, multiplying it by the maximum brake power, and of course the speed is not supposed to go up when we brake but down, and this is why for the 30 I've replaced it with a -30, so the braking acceleration is going to be negative at all times. Yeah. Now if we happen to reach negative speeds, which is when this if statement is false, then we're going to simply set the speed to 0. And now, with the help of the wait 0 seconds block, which is going to wait until the next frame, we are going to accelerate to a little bit of a speed right here. Let's do 80 kilometers per hour. And now, brake. Now we can actually stop the car when we brake, and it's not going to go into negative speeds. Now this is pretty much it for the basic movement of the car. Now of course we can add something that changes the speed, so we can simulate things like rolling resistance and drag. So we're simply going to set the speed to 0.997 times its original value for every single frame. I found out that this value works pretty well in pretty much every situation. Now we just have to check if the W key is not pressed, since we don't want the aerodynamic stuff to apply when we're accelerating, because that is already simulated in the acceleration code itself. And now if we accelerate a little bit, you can see that our speed is going down once we let off the W key. This is great. Now we've coded the basic movement of our vehicle. One thing we have to do now is that we change the global rotation, which is called rot here, and we're going to change it by the car angle times the car's grip. And this is where the grip value comes into play again. In this case it's 1, so the car angle is going to be applied to the global rotation instantly without any changes. I think this is a little bit too fast, so we should set the grip value of this car a little bit lower, maybe 0.6 or something. This should work fine for the car. Much better. Now it's not going to turn on a dime anymore. But how do we actually move the car once we have its physics done? Now the secret to this is sine and cosine blocks. Right here in the operators tab you can find this block, change it to sine, and here to cosine. Now we can take the cosine and sine of the rotation and multiply it by the speed of the car. Now usually if we take the raw speed of the car, it's going to be way too fast. I suggest you divide it by 75 first, so it should look something like this. What this is going to do is break up the movement of the car into its two components, which is in this case the movement on the x-axis and here the movement on the y-axis. And that's already the code for the physics completed. Now we can rename the sprite to car and import the 3D model you've made in the last tutorial. So now I'm using a slightly lower resolution model since the other one might make the game lag a little bit, which we obviously don't want. Now it is time to code the rendering of the car. This needs to be a custom block being run without screen refresh, with this variable being n, with the variable n standing for the number of the car you're currently driving. We put this custom block in a forever loop. And for the rendering of the car, in this case the 3D model is from top to bottom, but we need to start with the bottom sprite. So we're going to switch the costume to the last costume for now. This is a temporary solution. If we want to add more cars, we have to implement that later, but for now this is going to do the job. Now you need the amount of images your car is made of. In this case it's 26, so we're going to repeat this process 26 times. I'm going to chuck in a move to x0 and y0, but we're going to change the y to something like 70, so the car is not perfectly in the centers, but a little bit below, so we have slightly more room to see what's in front of us. Also, I recommend that you scale the car down since right now it's pretty large. Yeah, this should do the job. If we put it into full screen, this is somewhat fine. Maybe scale it up to 50%, but this should work. And of course you should not forget that we need the car number chucked in here as well, because otherwise this entire variable would be completely pointless. Now we need the pen extension, which you can find in the extensions tab, and right here you're going to have to add it so we can stamp the car. So now we have the code for the car rendering. Why am I repeating this 4 times? It's because that makes the model a little bit more accurate and removes some of the artifacts you might get when you only let this render once and with a higher change y by something value. So right now this is not looking particularly great, and you can see that the entire back of the car is gray, which doesn't look very good. So this is where Turbo Mode comes in. We click into Advanced, High Quality Pen, and this is going to improve the quality of the pen massively. Now of course the car looks a little bit tall, which a Honda S2000 is usually not in real life, so we're gonna have to tweak that a little bit. Now this looks somewhat fine, and that's pretty much the car rendering done as well. Now one thing we have to do to give us some visual feedback of what the car is doing, we can use the point in direction block. It's now going to point in the direction of the car angle plus 90 degrees, of course, since our car images, since all the images are facing up and not to the right, which is what you usually want in Scratch. And now the car is moving just like this. Of course we can make it even more accurate in terms of rendering by turning the repeat amount up and the Y change down. So now it's rendering the layers twice as often, and now we almost don't have any artifacts remaining. In my opinion this looks pretty good, so we can leave it there. Now onto the map. You need to create a new sprite here, which you're going to draw, of course, since Scratch does not have any maps by default. And now we can draw a little bit of a map in here. I'm going to make a fairly basic island, and I'm going to add some roads here and there, maybe increase the pen size to 20 or something to make the roads bigger. And now we have a road that loops around the island. Of course I'm going to add a few more to make the map feel a little bit more alive. And there we go. Now the map feels a lot more alive than I do. Great. Now we're going to make a new costume. Keep this empty. We're going to need this later for a little size hack. Now we're going to create a new forever loop. and a new custom block. Make this run without screen refresh as well. And this is where it's going to get interesting. But if I want to demonstrate this to you, I'm going to apply a little size hack in here, which is switching to the costume 2, which is the empty costume we have in here, setting the size of the map to something ridiculous like 700, which would usually not be possible for a costume of this size since it's already bigger than the screen. And we then switch back to the costume 1. Now we need to hide the costume so that we can stamp it. I've run into a little issue here since the car has priority in terms of code, and now we should delete the erase all and put it over to the map, since that is where we're going to need it, because otherwise the map is going to get deleted immediately once it gets stamped, and this is what we don't want. And now the map is being rendered properly. Now, unfortunately, if I turn to the right, the map is turning to the left, which is not ideal, and also the map is not aligned properly, which we're going to fix now. And first of all, we could perhaps want to move the car a little bit downwards, since it's a bit too far up for my taste, so move it to Y120. That's a lot better. And now you should do the same for the map, so it has the same origin point, or the same point of rotation, you know, the same origin point for where it's rotating as the car. And now this is the fix for the incorrect rotation of the map. Just negate it like this. And now the car is working properly. Now, since I'm dumb and I accidentally did this, it also negated the 90 degrees. So our movement was even more screwed, but this is how you do it correctly. Now, if you think that the car is moving a little bit slowly, or rather the map is moving slowly, then you're not the only one. So we're going to multiply the movement speed of the map by 3 or something. This should be a lot better, and make the car's movement feel faster. Yeah, there we go. That's a little bit more like it. Still not fast enough for my taste though. We're going to crank it up all the way to 6. Now we're going at acceptable speeds. The car is moving. The map is showing up as intended. It's a tiny bit laggy since I haven't enabled interpolation and stuff. But I think this is going to do for now. This is also possible on original Scratch without Turbo Warp. I just like to use Turbo Warp since it's personal preference. I've made a very old game. One of my very old games uses the same technique of, you know, rotating and moving the map behind the car. It's a really old game. I made it back in 2020. And yeah, it's a little bit outdated, of course. But yeah. I'm also seeing right now the braking is not sufficient for many of these tight turns, so we can double this and turn it to 120. Should feel better. Yeah. Also, the acceleration is slow, so we can put this to 35 or something. Yeah, this feels a lot more like the original Honda S2000 immediately. Yeah. I'd say this is a decent little solution. It's quite simple, doesn't take that much time, quite easy. And coincidentally, my game Pixel Rapper Motorsport is also using the same technique of layering multiple PNG images on top of each other to create the illusion of a 3D model of the car. And it also uses this script, but in a much more complicated form, to move the map around and move the car around and stuff. If you want to see more progress on the map, as I said, make sure to subscribe to the channel. I'm going to release the game at some point. I'm going to show you more gameplay. I'm at 41 cars right now. I have 6 maps. I have upgrades. I have game saves. All of that in Turbo Warp. With the help of some extensions. And I'm pretty proud of what I've achieved with that game overall. I'm definitely going to post more gameplay, even with controller. And yeah, if you enjoyed this video, make sure to leave a like and sub so you don't miss out on further uploads. Comment down below what you want to see me do next, or maybe make a tutorial on. And until then, I hope you have a great day. Goodbye.